student, so now we are going to solve one more example on Fourier series. So here we have to prove that in an interval 0 to pi, e to the power ax minus e to the power minus ax upon e to the power a pi minus e to the power minus a pi is equal to 2 by pi into this series of sine. Now guys, since I want this series of sine and the given range is from 0 to pi, it reminds me about one concept, and that is nothing but the concept of half range sine series, because in half range sine series we get all terms as sine, one thing, and second is there the range is either 0 to L or 0 to pi. So here range is given as 0 to pi. So here I am gonna find out the half range sine series for this function. So here I'll say let f of x is equal to e to the power ax minus e to the power minus ax upon e to the power a pi minus e to the power minus a pi. And now let's find out half range sine series for this. So here I'll say therefore half range sine series for f of x is given by the formula f of x equal to summation n equal to 1 to infinity bn sine of nx, because the formula is n pi x upon L and L is pi, so pi and pi cancel, so we will get sine nx. So I'll call this as equation number 1, and now I'm gonna find out the value of bn and we'll put that value of bn here to get the result. So let's start. So bn is given by a formula 2 upon L. So here L is pi, so 2 by pi integration 0 to pi f of x. So f of x is this term, so I'll write it down. So e raised to ax minus e raised to minus ax upon e raised to a pi minus e raised to minus a pi, that is f of x, into sine of nx dx. Now guys, let's evaluate this integration. So first of all, this term, that is 1 upon e raised to a pi minus e raised to minus a pi, is constant, and guys, that is why I'm gonna take that term outside the integration. So outside the integration we will get bn as 2 upon pi into e raised to a pi minus e raised to minus a pi. So this will be outside the integration. Inside the integration, that is from 0 to 2, 0 to pi, we are gonna get this bracket into sine nx. So let's multiply this bracket with sine nx. So we will get e raised to x into sine nx minus e raised to minus x into sine nx. So as here e raised to ax into sine nx minus e raised to minus ax into sine nx dx. Now let's evaluate the integral. So here I can apply the formula of e raised to x into sine bx. So guys, I'm sure that you know the formula, and even if you don't know the formula, you have to go back and revise the formula. But for my good students, I'm going to tell you formula over here also. So even if you don't remember the formula, you can see from here and you can do the copying of that formula. But guys, remember, I'm not gonna there with you in the examination. So for that you have to remember this formula from the exam point of view. So let's start. So integration of e raised to ax into sine bx dx is given as e raised to ax upon a square plus b square a sine bx minus b cos bx. So guys, I'll use this result. Now if I compare this question with the formula, value of a is a but value of b is n. So let's change the things. So bn will be 2 upon pi into e raised to a pi minus e raised to minus a pi. In the bracket, this term will be e raised to ax upon a square plus n square, in bracket a sine nx minus b is n, so n cos nx. Now this is the first value. So after this we'll put negative sign, so minus sign. For this, a is minus a, b is n. So let's apply the same formula again. So that is e raised to minus ax upon a square plus n square into a sine bx. A is minus a, so minus a sine of nx minus n cos nx, and this is from 0 to pi. Now let's put upper and lower limit. So upper limit is pi. I'll put that upper limit over here and then the lower limit. So therefore bn is equal to 2 upon pi into e raised to a pi minus e raised to minus a pi in the bracket. If I put a as pi, I mean x as pi, we will get e raised to a pi upon a square plus n square. I'll write down that term, e raised to a pi upon a square plus n square. So I'm substituting the upper limit. Next, if I put pi here, we will get sine n pi, and guys, sine n pi is 0. Here cos n pi, which is minus 1 raised to n, and minus n as it is. So I'll say here minus n into minus 1 raised to n. Next, negative sign as it is. Here e raised to minus a pi, a square plus n square. So minus e raised to minus a pi upon a square plus n square. Next, sine n pi, again 0, cos n pi, minus 1 raised to n into minus n. So minus n minus 1 raised to n. So this is what we got by substituting upper limit, that is pi. Now middle sign is minus, and now let's put the lower limit. So minus. Now for lower limit, we'll put x as 0. So e raised to 0 is 1. So 1 upon a square plus n square. 1 upon a square plus n square. Here x is 0. So sine 0 is 0. Cos 0 1. 1 into minus n is minus n. So here we will get negative n. Minus sign, that is this sign. Again e raised to 0, 1 upon a square plus n square. Sine 0 0. Cos 0 1. 1 into minus n is minus n. So 1 upon a square plus n square into minus n. Now guys, here you can see that this minus and minus is gonna be plus n upon a square plus n square, and minus n upon a square plus n square. We can cancel these two terms. Now from these two terms, I can take this n minus 1 raised to n outside because it's common, and a square plus n square outside. So we will get bn equal to 2 upon, now here this term, that is n into minus 1 raised to n outside. I can also take negative sign because it is there in both the terms, so minus n here, pi e raised to a pi minus e raised to minus a pi, and from denominator we will take 1 upon a square plus n square outside. Now guys, let's see what remains in the bracket. So this term is outside, this term is outside. From here only e raised to a pi will remain, minus this term outside, this term outside. From here e raised to minus a pi will remain. Now guys, can we cancel something? Yes, definitely. From numerator and denominator we will cancel the same terms. Now let's see what is remaining. So bn is minus 2 upon pi and n minus 1 raised to n upon a square plus n square. And guys, this is what the value of bn which we are gonna substitute in equation number 1. What is equation number 1? So here f of x is equal to this. So value of f of x is this. I'll put this value here, and I'll put value of bn here in the right hand side. So we'll say from equation number 1, left hand side is f of x, which is e raised to ax minus e raised to minus ax upon e raised to a pi minus e raised to minus a pi, equal to, now the value of Bn is this, in which minus 2 by pi is constant, so I will take it outside. So we will get minus 2 upon pi outside, summation n equals to 1 to infinity n minus 1 raised to n upon a square plus n square into sine of nx. Now guys, here we got the new equation, and now we will expand this by substituting different values of n so that we can get this result. So in this result you can observe that on the right hand side we have positive 2 by pi. So what I'll do is, here we got negative 2 by pi, I'll send this negative sign inside, okay, or I'll send it afterwards. I'll first expand this summation. So here we will get minus 2 by pi, in bracket let's put n as 1, so we'll get 1 minus 1 raised to 1 is minus 1 upon, here we will get a square plus 1 because n is 1 and 1, so sin x. Next, n is 2, so this will be 2 minus 1 square because n is 2, so minus 1 square is 1 upon a square plus 4 into sine of 2x. Next, n is 3, so minus 1 cube is minus 1, so minus 1 into 3, so minus 3 upon a square plus 9 because 3 square is 9 and sine 3x plus so on. Now guys, I'll take that negative sign inside, so we will get 2 upon pi in the bracket, this will become positive, so sine of x upon a square plus 1, this term will become negative, so minus 2 sine 2x upon a square plus 4, and this will become positive, that is plus 3 sine 3x a square plus 9 minus so on. And guys, if you will see this result, that is exactly matching with the question. So here we have proved the required result, and I am sure that you understood how I derived that result. If you want to learn more videos on engineering mathematics and Fourier series, then guys, do visit to ekeeda.com because that is the only place where you can find my all videos. Thank you very much.